there, lab friends. Today I'm hoping to answer the age-old question, what the heck is a quadratic formula and how do I use it? All right, so let's first recall what is this long, scary-looking formula. It looks like this. So x equals, so always remember what we're solving for. We're solving for our x-intercept. That is what this magic formula is solving. It's giving you the x-intercepts of your quadratic. So how you do that is you first need to identify what is your A, what is your B, and what is your C. So think about a quadratic in this form. So A is our leading coefficient, B is the coefficient on the middle term, and C is our constant term. So what you're going to do is you're going to take those coefficients and you're honestly just going to plug and chug them into this lengthy looking formula. But the benefit of this formula is it works every time. You can use it on any quadratic. So if you want, you could use this and never have to factor a quadratic again, which would be kind of nice for some of you who may not love factoring, right? Do you have to use it? The only time you have to use it is when factoring fails. So we can only factor when our numbers are rational. That means when they're nice whole numbers, integers, and nice fractions with nice pretty decimals. But we know that sometimes we get icky numbers, right? Sometimes that happens. So that's when you're really going to have to use the quadratic formula. Let's take a look at what that could look like, all right? So here's my quadratic down here, x squared minus 2. So let's first identify our A, our B, and our C. So A is the leading coefficient. What is technically being multiplied by this x squared? A nice 1. Is there any middle term? Is there any term with just an x? Nope. So that's going to be a 0. And then C, my constant term, is going to be a negative 2. Be careful you don't lose that negative. Because it is a minus 2, you need that negative 2, or we are going to mess ourselves up here. So just for the sake of fun, let me show you what would happen if you were to factor this quadratic. You would have to ask yourselves, what multiplies to a negative 2 but adds to a 0? Ooh, 2 is not, the only way I can multiply to 2 is 2 and 1. And that's never going to add to 0, is it? Think about it. What's negative 1 plus 2? Not 0. What's negative 2 plus 1? Not 0, right? In order to get 0, I need to have the same number, just opposites, like 4 plus negative 4. So that's just not going to work here. So when do you have to use it? When factoring fails. And this is a good example of factoring just not working for us. So we are going to have to turn to the backup plan. Plan B, I said that weird. The quadratic formula. So I'm just going to plug in my A, B, and C here. So I'm plugging in 0 for B. I'm plugging in 1 for A and negative 2 for C. All over 2 times A, which is 1. Alrighty. So that's the quadratic formula. So think of it as a backup plan. Now, every year I always have someone who really prefers it to factoring and using the zero products property, and that's totally fine. If you like this better, make plan B your plan A. That's totally cool. How I go about solving this is I take the discriminant first. So the discriminant is the name for the little expression underneath my root. The discriminant tells us a lot about our quadratic, so I always like to find that first, all right? So grab your calculator or your Desmos and just type in that little expression that I've highlighted. So we're going to just type in here 0 squared, so 0 squared minus 4 times 1 times -2, right? 4AC. And that gives us a positive 8, all right? So my discriminant is a positive 8. That is a good thing. If my discriminant was negative, folks, can I take a square root of a negative? No. So if I got a negative, then there would be no real x-intercepts. Actually, the x-intercepts would be imaginary, which you will get into in Algebra 2 in a couple years, all right? Let's figure out our denominator, folks. I think we can do this one on ourselves. What's 2 times 1? That's just 2. All right. So let's keep simplifying here. I know that I'm going to have 2 different answers, right? So I kind of like to break this up into 2 different slots here. -0, folks, is there anything? No, -0 is just 0. So it's just really 0 plus √8 divided by 2. Or 0 minus √8 divided by 2. So I've got to split it up into 2 separate sections, one for the plus and one for the minus, because it's plus or minus, okay? So now from here, you can plug these into your calculator or Desmos. So 0 plus √8, isn't that just √8? So √8 divided by 2. So we could leave it like that, or I know some of us like to simplify. So the square root of 8, and then we're going to divide that. What? No, I want the 8 in there. 8. Oh gosh, I'm messing up here. 8 divided by 2. And I get 1.41. So I get about 1.41, we'll say. All right. Now here, 0 minus √8, that's just going to be a minus √8 divided by 2. So that should be easy, right? We're just going to stick a minus out front. And I'm just going to get the opposite of that first answer, -1.41. So that just shows that my 2 x-intercepts are going to be positive 1.410, and the other one is going to be negative 4.10. And if you don't believe me, or if you want to check your answer, we can use our third method for finding x-intercepts. So the first is factoring in zero product property. The second is the quadratic formula. And the third way to find x-intercepts is just to graph on here. So I can just type in here y equals x squared, and then make sure you come back down on the ground, minus 2, right? That was my quadratic. So we can see here, guys, if I just click on the x-intercepts, I get 1.41 and negative 1.41. So we know we got it right, all right? So those are really the big ideas for the quadratic formula. I just really want to circle back. You always have the option of factoring in zero product property, quadratic formula, and then you can always graph as well. And just remember, based on the quadratic, it might be, you might have to use one of the method, but you can always try all 3. But like for this one, we had to either use the quadratic formula or graph because our intercepts were those icky irrational decimals, all right? So this is just another tool you can stick in your algebra toolbox and use it when you need to, all right? Make sure you email myself or Mr. Widener or one of your algebra teachers if you have any further questions. We are